Hello everyone, this is Mr. Appel, and today I'm going to walk you through graphing a rational function for a case 1, but a case 1 that's a little bit unusual, so it'll help you with basic case 1s, but also kind of help you with this particular one that has some slightly unusual behavior, but nothing too crazy. Okay, first of all, I know that this is a case 1 because the degree on the top is 0, degree on the bottom is 2, and so the top is smaller than the bottom. That's a case 1. Okay, going to look for any factoring that I can do here, and I do see that the bottom is factorable. Clearly not going to be any holes since there's no variables at all in the top, so no factors are going to cancel out. No x terms are going to cancel out. So no holes to worry about here. X-intercepts, though, are interesting. X-intercepts, again, are when the whole thing is 0. Only way that can happen is if the numerator can be 0. Well, what x value makes -2 0? Exactly, none. Can't happen. So there is no x-intercept. And we can determine that pretty easily because, again, there's no way that that numerator can be 0, which means the whole thing can't be 0. Y-intercept, that's when x is 0. So if you plug 0 in for x, you got -2 on the top and -2 on the bottom, which is 1. So our x-intercept is at 0, 1. I'm going to go ahead and plot that on my graph so I have it. Vertical asymptotes, I've already factored the bottom, so I see there's going to be 2 of them. So x, that's the zeros of the denominator, so x equals -1 and x equals +2. So I'm going to go ahead and sketch those vertical asymptotes. Now I'm going to look for end behavior asymptote. This is the easy one. Case 1, the end behavior asymptote is always y equals 0. So that's just the x-axis. Okay, I should be drawing arrows on those. Sometimes I'm a little lazy about it, but you really should include them. Okay, so now we have one of these cases. 2 verticals and 1 end behavior. So there were actually 4 possibilities of what this could look like. And remember, we start with the middle. And those 4 possibilities are it could be like cubic looking in the middle, either way, or it could be parabolic looking in the middle, either way. So 4 different possibilities. So how are we going to determine which one it is? Well, let's do that now. I see this point here, so there's a point right there. So that eliminates the upside down parabola, because that wouldn't hit this point. And it really eliminates the cubic that goes this way, because that really wouldn't hit that point. So what I'm trying to determine now is, does it do this, or does it do this? So if you're not sure, there's always a good strategy, which is to make a small table and just pick, in this case, really only need maybe 1. If you see what happens like at x equals 1 here, if you get a positive, then you know it's going to turn around and go back up, but if you get a negative number, then it probably went through. Keeping in mind it can pass through that horizontal asymptote, and it will do that sometimes. So I'm going to go ahead and do that. I'm going to plug in x equals 1. And I see that that gives me -2 on the top, and that gives me -2 on the bottom, which is +1. So 1, 1 is another point on my graph. So now I can see pretty clearly that this thing is going to have to turn around and go back up. Now, you actually, in this case, could have determined that that's what happened, even without doing this work, because of this little guy over here. There was no x-intercept. So there was no way this graph was ever going to cross the x-axis. So hopefully you were thinking that as I was talking about the 4 options. If you weren't, that's okay. You just need to use your understanding of what's happening to determine what's going to go on in the graph. So, you can be clever, or you can plug in a couple of points just to be sure, as long as you understand how to determine that this is what's happening. The rest falls into place. This one has to be doing something like that, and this one has to be doing something like that. And that is the sketch of our graph. The asymptotic behavior, we've got 2 asymptotes to worry about. I've got -1 from the left. -1 from the left, it's going down to -infinity. As x goes to -1 from the right, So as I come at -1 from the right, I see it's going up. So that's positive infinity. And then the other vertical asymptote is at 2. So as it approaches 2 from the left, that's going up. And as it approaches 2 from the right, sorry, running out of space there, as I approach 2 from the right, I see it goes down. So that's going to negative infinity. In behavior, so as x approaches negative infinity, where does this thing go? Well, the end behavior asymptote tells us that both ends go to 0, and I can see that as I go out towards negative infinity, I get closer and closer to the x-axis, which of course is y equals 0. So it's approaching 0. And the limit as x approaches positive infinity, same thing, it's approaching 0. Keeping in mind you should be writing this in proper limit notation. If you do this as a shortcut, that's fine, but you, on a test or a quiz, anything formal, you really should write it in proper limit notation. That's all. I hope this was helpful. Thanks.